Hello guys, I'm going to talk about GlusterFS today. GlusterFS, I mean Gluster file system, is a scalable network file system. Now, where does this GlusterFS fits in? Suppose you want to create a cluster. For example, you want to create a 3-node web cluster. So you have 3 web servers running in 3 different nodes, and you have application in one of the folder. And since your application is the single source, so you need to provide all these 3 servers access to that single source, so that if one of your server fails, the other 2 servers have the same access to the same files and they can same source, so that they can serve from there. And that means that you need a single storage shared among all these 3 nodes. But normally what do we have? Normally we have regular servers where individual server has their own storage, and most of the time we don't have the network shared storages because those are a bit expensive. So GlusterFS kind of gives you an opportunity to share this local storage attached with individual servers, and then kind of like bring them together, and so that if you write on a local storage on one server, that file or that data gets replicated with other servers, that the servers that are participating in GlusterFS. So that means when you write a file in one of the servers Gluster volume, that file gets copied over to other participant Gluster volumes. So without having a network attached storage, you get the same functionality with this GlusterFS. So GlusterFS is highly scalable. That means you just can add additional servers or additional storages with your existing servers and add them to the Gluster file system. And that aggregated storage from all these servers, you get a large storage in a single namespace. There are other few advantages using GlusterFS. GlusterFS can handle petabytes of data, thousands of clients, and it's compatible with all other Linux flavors. I will give you a little bit of technical aspect of GlusterFS. How does it work? So GlusterFS is a user space file system. It is not a regular file system. The regular file system normally managed by kernel, but GlusterFS is executes inside the user space. So GlusterFS normally interacts with the fuse. So whatever the language the fuse supports, you can use that language to write your own Gluster file system. So in this example, what I see, hello is a Gluster file system, and this to this hello Gluster file system we are passing the mount point /tmp/fuse, and when a user executes a command in that file system, for example ls-l in the temp/temp/fuse, that request goes to the VFS, and VFS knows that it is going toward a Gluster file system in the user space. Then it passes the request to the fuse, and fuse is the interface with the GlusterFS, and it executes the command and passes back the result back to the user. So fuse is the intermediate interface between GlusterFS and the kernel. GlusterFS supports different types of distributed file system. So one of them is it is called distributed, and this one is the default, but this one doesn't have the redundancy. And this is the command you see how to create a distributed Gluster file system. I'm saying here create a volume named test-volume, and that volume consists of the folders exp1 from server 1 and exp2 from the server 2. And if you look into this picture, if you see the file 1 is stored in server 1, file 2 is stored in server 1 as well, file 3 is stored in server 2. So there you see there's kind of no redundancy. So it is, if you want redundancy, then this is not your choice, but this is what it supports, and this is called the distributed volume. It also supports some of the other types of volumes. This one's called replicated, and replicated means that it has the files normally has copies in different servers. So you have the redundancy, and also you have improved I/O. It also supports distributed replicated volume. That means your file is has a copy, different copy, so you got the redundancy, and some of the files are also stored in the servers, so you kind of have distributed storage. But one of the things you have to remember that number of bricks in this distributed replicated volume must equal to be multiple of replica count. And here you see the command we are saying the Gluster that create a volume test-volume with the 2 replicas. That means that the file 1 will have 2 copies. And here we say TCP is the transport layer. TCP is the protocol for server 1, server 2, and server 3, server 4 to communicate with each other. And you see the folders shared from the servers, like in the server 1 it has exp1, and the server 2 exp2, and so on. It also has a striped volume. File is basically data is basically striped into multiple pieces and stores across servers. So, but this one doesn't have the redundancy, but you have the improved I/O. So if you kind of need if your data is important, then this one is not the right choice. But if you want performance, this one gives the performance. Distributed striped, it is same as the distributed striped, but same as striped, but it is a distributed one. Now here's an example how to create a Gluster volume and how to mount that volume so that you can use that. This example shows the default, distributed Gluster volume. So here we consider that we have 2 servers, and every server has /dev/sdb1 storage device attached with them. So we create, in the first line we are saying that create a file system on dev/dev/sdb1 with the block size 512K, and /data/brick1 would be the mount point for this device. And we are adding an entry, we are inserting a line in the /etc/fs tab, so that when the server reboots or when the server starts, it also mounts the device in this specific brick1 folder. And the next, this is the command to mount the file system. Once this is done, this is pretty basic. You don't have to, this is not actually related to the GlusterFS, but Yeah, when you add a device, storage device, you normally create a mount point and mount it. Gluster files, GlusterFS-server is the package for Linux. This package is for specific to the Red Hat systems. So you install this service. Once you install the service, and the following line, I started the Gluster daemon. And also you have to make sure that if you are having IP tables running in your system, then you must allow packets through between these two servers. So we are basically saying IP tables that in the input table all the protocols ports are open and accept the connections. And now we are creating another folder in /data/brick1/gv, and this gv0 is basically, we say, is a brick. Okay, so we create a similar folder on both of the servers, because whatever you write, that data will be stored in /data/brick1/gv0 on any of the servers. Once you have done this on both of the servers, now go to any of the servers and then create a volume. So we are saying Gluster create a volume gv0 with the replica 2, and the location in server 1 is /data/brick1gv0, and in server 2 it is /data/brick1gv0. So successfully, if you create if this command is successful, you get a gv0 volume, and then what you have to do, you have to start the volume. So once you start the volume, you have a volume running, and then now you need to mount that volume on each of the server. So on both server, you go to the as a root, with the root privilege, execute this command. So remember that this is pointing to server 1. So in your case, you have to do actually on both server 1 and server 2. So mounting this gv0 volume, this cluster volume on /mnt. So once you do this on both of the server and it's successful, you can you can use this command in any of the server and see the information about the volume being created. Now whatever you write in /mnt will be replicated, will be copied under /data/brick1/gv0 folder on both of the servers. So in this example, we actually use this local device attached to both of the servers, and then created a gv0 cluster volume, and this volume is like it's a cluster volume, so it is shared, and whatever you write in the gv0 the mount point in a /mnt, it gets replicated across all the servers and storage participating in this cluster volume. Thank you guys for listening.